For decades, Neptune was little more than a mysterious dot at the edge of our solar system. Cold, blue, remote. But when renowned astrophysicist Neil deGrasse Tyson stepped onto the stage of a recent global symposium, what he revealed about this icy giant didn't just surprise the public, it shook the scientific community to its core. His message was clear. Neptune is not what we think it is. Speaking to a packed auditorium, Tyson delivered a stunning update grounded in new data from the James Webb Space Telescope and advanced Earth-based interferometry. These aren't the fuzzy telescope images of the past or the fleeting snapshots from Voyager 2's 1989 flyby. What we're looking at now are patterns, gravitational, magnetic, thermal, that defy everything we thought we understood about ice giants. From the very beginning, Neptune was an oddball. It wasn't even discovered through direct observation, but through math, its presence inferred by strange deviations in Uranus's orbit. Ever since, it's been orbiting quietly in the shadows, largely untouched and unexplored. Until now. What Tyson revealed painted a radically different picture of this distant world. A planet with an interior that behaves like a living system. Instead of neat layers of rock, ice, and gas, Neptune seems to host chaotic, interacting zones. Regions where plasma-like materials swirl through the depths, and inexplicably warm patches exist where there should only be frigid cold. And that warmth? It's not coming from the sun. At Neptune's distance, solar energy is a whisper, nor does the planet have a massive moon exerting tidal friction. So what's generating this heat? Tyson pointed to something unexpected: internal dynamism. Deep within Neptune, some mysterious mechanism is creating more energy than our models can explain. An energetic core that might challenge the very physics we rely on to understand planetary behavior. But that's not all. Neptune's magnetic field has long been a curiosity, oddly tilted and offset. Yet new data reveals something stranger. It's not just misaligned, it's unstable, constantly shifting in patterns never before observed. Sections of the field drift, collapse, and reform. Tyson suggested that the magnetic dynamo at Neptune's heart may be unlike anything in the rest of the solar system. Not a swirling metal core or hydrogen shell, but a realm of exotic ices undergoing bizarre transformations under immense pressure. This leads to one of the most mind-bending possibilities discussed. Neptune might be partially hollow. Not in the way conspiracy theories claim, but in a scientifically compelling sense. Stratified cavities within the planet acting as resonant chambers for electromagnetic energy. If true, this discovery could force a rethinking of how we categorize and model not just Neptune, but all planets. The implications ripple outward. Neptune's gravitational pull helped shape the Kuiper belt. It may have flung a fifth giant planet out of the solar system in its youth. But if Neptune itself is more chaotic, more alien than we imagined, then so is the story of our solar system's formation. Then came the radio emissions. While Neptune has always emitted radio waves, standard fare for a magnetized planet, the latest signals don't match anything we've seen before. These bursts seem to originate from deep within, and their frequencies suggest processes beyond mere atmospheric turbulence. Could they be signs of quantum behavior under intense pressure? Are we witnessing physical states not seen since the birth of the solar system, or anywhere else? Even more extraordinary was the discussion of Superionic ices. These exotic materials, theorized for decades, act as a strange hybrid of solid and liquid. Inside Neptune, they may flow like slush, carrying electrical charges and driving its wild magnetic behavior. This electrified soup could be cycling deep beneath the surface, feeding storms and magnetic storms with an energy source we've barely begun to comprehend. Speaking of storms, Neptune has the fastest winds in the solar system, over 1,300 km/s. Traditional explanations chalked it up to atmospheric rotation. But Tyson proposed a new idea. What if the winds are driven from within? If Neptune's weather systems are born from internal thermal pulses, bursts of energy rippling up from its core, then it would be the only known planet whose climate is generated from the inside out. This isn't just about Neptune anymore. Thousands of exoplanets have been labeled mini-Neptunes or sub-Neptunes. If our Neptune is already this strange, what does that say about all the others? Tyson emphasized that we may be grossly misinterpreting their compositions, their atmospheres, even their potential habitability. Our assumptions, built on shaky ground, may be dangerously outdated. One of the most provocative ideas presented was whether Neptune belongs in a category all its own. It doesn't have the mass to become a star, but its internal activity, its heat, its dynamism, suggests it sits on a spectrum between planet and brown dwarf. It could be a missing link, a celestial body that challenges the binary classifications we've long depended on. In Tyson's own words, Neptune might be a chaotic system in equilibrium, a planet balanced not by stillness, but by turmoil, a self-sustaining engine of unknown processes pulsing at the edge of our understanding. And perhaps that's the most powerful takeaway of all. Neptune was once just a cold, blue blur. But now it's a reminder that in science, the quietest objects can hold the loudest secrets. That the edge of our solar system is not a border, but an invitation. As Tyson concluded, none of this would have been possible without our latest tools, the James Webb Space Telescope and next-gen ground observatories. It's not that the universe has changed, it's that we're finally beginning to see it. And what we see changes everything.